monuments to the art of building. These are the space enclosures in which we work and live, the shapes and the textures of our man-made environment, our cityscape. As such, they influence even our lifestyles and the patterns of our society. The builder's decisions affect all of us, all our lives. He has great power and responsibility. The Center for Building Studies at Concordia University was established in 1977 for training future leaders of the building industry while still playing an active role in the industry as a center for research, development, and information transfer. The emphasis at the center is on 4 areas of building engineering: building environment, building science, building structures, and construction management. Within each of these areas, attention is focused on all aspects of a building project. The building engineer is, in a sense, the modern equivalent of a building professional who shaped an earlier age of construction, the master builder. Until the 19th century, a building project was often a straightforward process involving limited technology. One man could take on the responsibility of overseeing and coordinating an entire project, seeing it through to a successful completion, the master builder. Today, however, there are new demands on the industry. Ever larger and more complex projects are proposed, while current economic constraints demand efficiency and cost-effectiveness in the building process. It is within the process and product itself of building that changes are occurring. New demands have created a new role. Meet the building engineer. Trained in all the main areas of building, his aim is to integrate all the many facets of the building process so that a project runs as efficiently as possible. The building engineer is an important member of the team of professionals who build and will continue to build environments that meet the needs and aspirations of our complex society. His responsibility is to search for new methods, to conceive and construct the most economical, functional, secure, and energy-efficient buildings possible. The multidisciplinary team of faculty, research, and technical personnel at the center is committed to both the development of competent professionals and the advancement of new technology for the industry. Each member contributes a specialized knowledge towards the team objective of finding new solutions to some of the current problems in building, while also providing students with a unique in-the-field preparation for the building industry. The Center for Building Studies offers a variety of undergraduate and graduate programs. The 3-year undergraduate program leads to the awarding of the Bachelor of Building Engineering. The Master of Building Engineering program enables graduate engineers to specialize in their areas of interest. The Combined Degree program integrates both the Bachelor and Master of Building Engineering to allow some students to accelerate in their area of specialization. Finally, the Faculty of Engineering offers a PhD program with a concentration in building studies. Many courses are conveniently scheduled in the evening in order to encourage the participation of practicing professionals. Let's take a closer look at the 4 areas of concentration at the center. Within the area known as building environment, emphasis is placed on thermal environment, acoustics, and lighting levels. This area includes the analysis and design of conventional building mechanical systems, sound insulation and noise control, and innovative systems such as solar energy. Building science emphasizes construction materials, building enclosure systems, and industrialized buildings, together with those basic sciences influencing a building's operation. Building structures concentrates on principles of structural analysis, design, and application of these principles to the investigation of building structural systems and wind aerodynamics. Construction management emphasizes both what is being managed and the techniques of management. It includes a treatment of legal and labor issues in construction, the techniques of planning, scheduling, and controlling of construction projects, and methods of construction. The Center for Building Studies is not a conventional school. It combines education and research development and information transfer to the building industry. In the latter area, computers are creating an important impact in the construction industry. Their implementation can affect many phases of construction, such as planning, building operations, and maintenance. In response to this technological advancement, the center has established Siricon, a nonprofit corporation designed to create computer software for the industry. The objectives of Siricon are threefold: to gather computer technology appropriate to the construction industry, to develop software for architects, engineers, contractors, and professional associations, and also to produce an organized body of knowledge and expertise in computer software for the industry. Research is initiated in response to specific requests from the industry and can be undertaken in the center's facilities. The Building Materials Laboratory, set up for the research and development of materials such as polymers, insulation, bricks, and tiles. The Thermal Insulating Materials Laboratory, accredited by the Standards Council of Canada, provides professional services in the evaluation and analyses of the thermal performance of new products and components. The Building Enclosure and Prototype Laboratory was established for studies that require large, dimensional, or full-scale sample testing, such as construction panels, beams, and walls. The Building Acoustics Laboratory, where research in sound measurement and testing can be performed. The Energy Conservation and Thermal Environment Laboratory permits research in heating, ventilation, and cooling systems in buildings. The Building Aerodynamics Laboratory features a large wind tunnel for evaluation of wind effects and airflow on and around buildings. Unique in the region, the computer-aided Building Design Laboratory is used exclusively for designing buildings. Graduates of the Center for Building Studies enjoy a remarkable variety of career opportunities. You'll find them working today in many areas of the building industry, often pioneering innovative designs. Avtar Paul, for example, is a 1979 PhD graduate in building structures from the Center for Building Studies. For the last 4 years, Avtar has worked with the SNC Group in Montreal. In 1983, with the aid of grants from the National Research Council, Avtar, in conjunction with Professor Cedric March of the Center for Building Studies, invented an earthquake resistance device that has since been patented in 10 countries. The device acts as a friction brake joining two steel surfaces. It therefore operates as a safety valve, limiting the damage caused to buildings by earthquakes, an invention that could revolutionize construction practices in earthquake-prone countries. That same year, both Avtar and Professor Marsh received the American Society of Civil Engineers' most prestigious award, the Raymond C. Reese Research Prize. One of Avtar's colleagues at SNC is another graduate of the Center for Building Studies, Xenia Vrouvides. Xenia graduated with a master's degree in building environment, specializing in acoustics and noise control. She is now employed in the Department of Noise and Vibration Control at SNC. Her work has ranged from acoustical consulting for the Canadian Embassy in Riyadh, Saudi Arabia, to designing methods for minimizing noise produced at a local refinery. Xenia's work is to ensure that the noise and vibration produced in and around buildings plays as little a part in our lives as possible. Yves Sylvestre is a graduate of the master's program in construction management. He works at Lavalin DMA, one of Canada's largest engineering firms. Yves is a microcomputer specialist. He has worked on a variety of Lavelin's local projects, as an estimator on the project Bay James, and as a director of cost planning management at Complex Guy Favreau. Presently, he is one of the project managers of the Old Port project in Montreal, a position that includes cost estimating, procurement, planning, and scheduling. Melese Tigani is now completing his master's in building sciences at Concordia, while working at Building Products of Canada Limited, a division of Esso. Melese's work is concerned with investigating the development of new materials, as well as improving existing products. Whether he's developing methods to strengthen fiberboard or identifying techniques to improve the durability of asphalt in roofing materials, it's all part of Melese's effort to produce better building products. His experiments with adding polymers to cement have led to stronger, more durable cement, the basis of stronger, more durable buildings. Reduced to the bare essentials, building concerns itself with the problem of providing shelter for people, suitable to their needs. Nothing more, but nothing less. It is a simple necessity, and yet building represents a complex task, particularly in today's world. The work of the building engineer is the constantly developing process of improving the conditions of shelter. Essential to this work are the research and educational facilities, such as those established at the Center for Building Studies. Our doors are open.